Hello. So this is going to be a little reminder of what we did in class with solving equations. So we have an equation. We use the examples of patterns when we were doing this, but let's say we're given an equation like this, even with no context, which can be kind of strange. The strategy we were practicing was the do-undo method. Okay, so we start with a little table. And then I always like to do my arrows. So we start with the do side. So I'm going to ignore that minus 16 and I'm going to think about what would I do to the x first. I'm always thinking about PEMDAS. Okay, and remember, all I see here is multiplication and addition. So if I think about which one comes first as I go left to right, well, first I would do my multiplication. So I would multiply by 3 first. Once I did that, I would add 5. And again, I'm thinking about if I plugged in a number for x is just a placeholder. And then I ignore that and I think, okay, what's the opposite of adding 5? Subtracting 5. And what's the opposite of multiplying by 3? Well, it's dividing by 3. Now we've got we had an equation, but now we have a specific point where we want to find what x equals. So remember when we were doing those patterns in class with the task, we were undoing them the other way. So I'm going to take my negative 16 and I'm going to start by subtracting 5 from it. And when I do that, I get negative 21. Done. And then my second step is that I'm going to divide that number by 3. And when I do that, I get negative 7. What this means is when I plug negative 7 in for x, in this equation, I have equality. This side would equal negative 16 and this side would equal negative 16. Now I can check my work, okay? So my check becomes, well, is it actually true? 3 times negative 7 plus 5 equals negative 16. Well, is that actually equal? 3 times negative 7 is going to be negative 21. Remember, that's the do side. Plus 5. And negative 21 plus 5 is negative 16. It works. Okay. Now let's try another one. We also looked at fractions, right? And we also looked at parentheses. There were all sorts of little weird things that we were doing, but they always linked back to order of operations. But let's go ahead and look at a fraction. So if we look at our fraction, we have, here's a problem. So we're going to have 2/3 x plus 2 equals negative 8. Okay. And we're going to do our do-undo chart. Okay. And remember, we can think of this as two things. Okay. We can think of this is x divided by 1. And so another way to write this is 2 times x divided by 3 plus 2 equals negative 8. So if we think now what we're going to do first, right, if we ignore the negative 8, the first thing that would happen is what's on top of the fraction bar because it's over both of them. So the first thing I would do is multiply by 2. Then I'd have to take that answer and divide it by 3. And then I would add 2 to it. Again, remember, I'm going in order of PEMDAS. Okay, I'm going to do my multiplication and division. I'm going to do my addition and subtraction. And really, this up here is kind of pretending like it's a parentheses. Okay, and then my undo side, I'm going to do the opposites. Negative 2 times 3, divide by 2. Now we bring in this old negative 8. This was our rule, but we want to know a specific time when this rule comes out to be this. So we want to know what the step number is when we have negative 8. So I take negative 8 and I'm going to go in order. So first I'm going to subtract 2. And then I'm going to multiply by 3. Notice that I'm doing this in steps. I'm not just keeping this one run-on line. The run-on line is not a true fact. Negative 10 times 3 is negative 30. And so did this. Last but not least, negative 30 divided by 2 is going to be negative 15. Don't forget, Whether it's a mental check, a calculator check, or a paper check, you should be doing a check. Okay, so I'm going to do a paper check. So 2 times 2/3 times -15 equals, oh geez, plus 2 equals -8. Okay, so when I multiply fractions, you may or may not remember this, which is okay. You multiply the top and the bottom. So we get -30 divided by 3 plus 2 maybe equals -8. -30 divided by 3 is -10 plus 2, and that does equal -8. So it checks out. Okay, so you're going to do a couple problems of these do-undo problems. Remember the do-undo process. Do is based on PEMDAS, and the undo is based on undoing PEMDAS. Hence the name, right? Okay, take care.